Physical science time. We're going to talk about, my book.
You did it wrong.
I did it wrong. Physical science time, again. This time with the book. We're going to talk about page 516. Physical science time, we're going to talk about the periodic table. You have seen a periodic table. I know you have because I handed one out not very long ago. I also have, this is not going to be useful with the camera, but I have this little guy. Do you see this? What this is a periodic table, but I made a little 3D sculpture of it, which is, I think, pretty cool. The periodic table, if you are watching online, like maybe our friend Carter, or our other friend Allie, or Josh. Yeah, Josh is our friend. If you're watching online, like Josh probably is, I would say almost definitely. If you're watching online, you can access the periodic table by going to www.google.com and typing into the little search bar, periodic table, and then pressing search, and then pressing
I thought you said you wasn't going to
You really said that?
No, go for
in the middle.
I'm out.
Okay, you can find a periodic table of your own using the internet. Okay, so I hope you have your periodic table in front of you because we're going to talk about it quite a lot. You'll notice it's this kind of interesting, or maybe even you would consider odd shape.
Yeah, why is that?
Yeah, why is that? Excellent question. So this is the rough shape of the periodic table. We're going to go through and we're going to name each of these things. The first thing you need to know is that, and you need to memorize this, the vertical columns on the periodic table, shh, stop talking please.
Staring at.
Shh, stop talking. The vertical columns on the periodic table, vertical columns are called groups or families. There are two words for the vertical columns, groups or families. Both of those are fine. What direction does vertical go? Show me with your hand.
Oh.
Yeah, up and down, right? So the up and down regions of the periodic table are called groups or families. The horizontal rows on the periodic table are called periods. What does the word periodic mean? Why do we call it a periodic table? I mean, let me answer those as two separate questions. What does the word periodic mean?
It's
For something to be periodic means what?
it's like it happens here, then happens here, then happens here.
Yes, we might even say there's one verb we could use to describe that.
Reoccurring.
Fine. Yeah, that's fine. I was going to say repeating, but reoccurring is fine as well. So for something to be periodic, like a periodical, have you ever heard of a periodical? Maybe Mrs. Creech has talked to you about those. Periodicals are what sometimes people, maybe the elderly, maybe not, sometimes people call things like newspapers or magazines that come periodically, right? They come, the Crawford Clipper comes once a week, Wednesday, right? Once every Wednesday, so it's periodically. Every Wednesday I know I'm going to get a Crawford Clipper. Every Thursday I'm going to throw it away. It's periodic, right? So for something to be in a period, it means that it's going to have a repeating pattern. So let's write that down. So we have, the reason it's called the periodic table is that there's repeating patterns of elements. Repeating patterns of elements. In fact, what's cool about this is that the man who made this all up, and we're going to watch a video about him later, by the name of not that many eyes, Dimitri Mendeleev. So you need to write down this man's name. It will be on your test. Dimitri, this is a Russian name. Dimitri, and his last name is Mendeleev. It looks like Mendeleev. It's pronounced Mendeleev. He came up with the arrangement we currently have for the periodic table by noticing that when the elements that were then discovered were arranged in order of increasing atomic mass at the time, which we will talk about, or we have talked about why that's not exactly how they work. But when they were arranged from increasing atomic mass, they had periodic patterns. He noticed that it would always go, for all the periods, light metal, slightly heavier metal, non-metal, 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 and then there'd be gases. And then start over, right? At the time he said every 7 elements the cycle would start over. And then there would be new added in, because then when we go to period 4, we have light metal, slightly heavier metal, then 12 what we call transition metals, metalloid, 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 non-metal, gas. And so he noticed this repetitious pattern, this periodicity, right? This repeating pattern of elements, and he arranged them in this way, which was, you can make all fun of me if you want. You always do, probably outside here, like, you know that idiot, Mr. Kime. But I think this is the coolest human invention ever. I mean, this is the biggest triumph of human thought and organization that has ever occurred. This we can think of this almost, this is how elements, which are fundamental things of the universe, right? An alien on another world may or may not exist, but they would be able to determine that the elements exist in the way that we have determined. They might not organize them exactly like this, but they would have some organization that recognizes the periodicity of the elements. They have to, because the elements have fundamental properties of the unit, or they have fundamental properties of chemical reactivity, of appearance. And so an alien would come up with an idea very much like this one, maybe not exactly a periodic table, but they might come up with this little squiggly looking thing that I have here.
That looks weird.
This is really cool. I love this thing. We're going to talk about this later. I'm considering having you guys build your own one of these as a project to illustrate how that works. But they're organized this way because of how many electrons they have. That's the next thing we're going to talk about. Electrons determine chemical properties. Specifically, and you should write this down, specifically what we call valence electrons. For an electron to be considered valence, it has to be in the outermost energy level. Recall back to the Bohr model of the atom. We had a nucleus surrounded by several energy levels of electrons. Not every atom has 3 energy levels. Some have more, some have less. But in this little drawing that I've done, only the atoms in this 3rd energy level would be considered valence. You have a question, Kaya?
Yeah, I didn't know what that word was.
Which word? Did you get it? This says electrons
So it's
determine.
valence.
Oh yeah, valence. V-A-N. Whoop. No. V-A-L-E-N-C-E. And that's another word for outermost. The outermost.
I
is-
wrote overnight.
Don't write that. What's up? Did you have a question? Okay.
You said
Another thing we should know about the electrons in the atom is that all atoms, except hydrogen and helium, are most stable with 8 valence electrons. This is another fundamental rule. In a second we'll talk about why hydrogen and helium are exceptions, but we call this principle the Octet Rule. Why might it be called the Octet Rule? What's oct mean? 8. Yeah, like an octopus has 8 feet.
that's what mom could be.
Yep. Octomom was how many kids she had?
8 moms?
She had 8 kids.
8 kids. 8 kids, right? Octomom. She had 8 kids. So Octet Rule tells us that all of the atoms, except for hydrogen and helium, all of them are most stable. Sometimes when we're being casual, we might say they're happier with 8 valence electrons, but they're all more stable with 8 valence electrons. They're all more stable. And so, in this way, the number of valence electrons they have cycles through the periodic table. We're going to run out of time real quick, but we'll pick this up tomorrow. But these columns are organized by their number of valence electrons. First column has 1, second column has 2. We skip these ones in the middle. Third column has 3, 4, 5, 6, 7. The final column has 8. So what does that tell you about the final column before we go? They're the most stable. They're the most stable. We're going to pick this up tomorrow. Have a nice day.
Bye.